Here is a number that should stop you mid-scroll. $750 billion. That is not a typo. That is the size of the web of deals Nvidia is currently building across the entire artificial intelligence industry. And here is the twist nobody saw coming. Right when Nvidia's empire looks unstoppable, a strange new problem is creeping in from a completely different corner of physics. Quantum computing. Not as a competitor to Nvidia's chips, but as something far stranger, a threat that could quietly undermine the very foundation the entire $800 billion AI build-out is standing on. Stay with me, because by the end of this video, you will understand why some of the smartest people in tech are suddenly nervous about a technology most of us assumed was still decades away. Let's start with the scale of what Nvidia is actually doing right now, because most headlines do not do it justice. Nvidia just posted fiscal year revenue of around $216 billion, up 65% from the year before. Nearly 90% of that came from data centers. That alone would be a staggering story. But Nvidia is not just selling chips anymore. It is becoming the financier, the landlord, and the supplier of the entire AI ecosystem at the same time. In the last few weeks alone, Nvidia unveiled a partnership with South Korea's SK Group worth more than $500 billion in combined business. It is also in talk as to backstop as much as $250 billion to help OpenAI lease computing power from a massive data center project in the United States. Add those two deals together with the rest of Nvidia's investment web, and you get a number north of $750 billion flowing through one company's fingertips. Think about what that actually means. Nvidia is not simply a chip supplier waiting for orders anymore. It is writing checks to companies so those companies can afford to buy Nvidia chips. That is the part that has made investors, journalists, and even famous short sellers extremely uneasy. It even has a name now, circular financing. Nvidia invests in a company, the company uses the money to buy Nvidia hardware, and the revenue flows right back to Nvidia's balance sheet, making growth look stronger than it might be on a purely organic basis. Michael Burry, the investor famous for calling the 2008 housing crash, has publicly raised red flags about exactly this pattern. And he is not alone. Reporters from Bloomberg, The Information, and the Wall Street Journal have all been digging into the same story over the past month. Here is where it gets even more tangled. Nvidia's rival AMD is investing $5 billion into Anthropic, a competitor to OpenAI. Anthropic then turns around and uses AMD's chips. Meanwhile, Anthropic has also taken billions of dollars from Google and Amazon, and in return commits to using billions of dollars of their chips too. Everyone is investing in everyone. Everyone is buying from everyone. It is a closed loop of money that keeps the entire AI machine humming, at least for now. Some analysts think this is simply how a young capital-intensive industry bootstraps itself. Others think it is the exact same warning sign that preceded some of the biggest financial bubbles in history. Either way, the sheer size of it is unprecedented. Microsoft alone plans to spend more than $190 billion this fiscal year on AI data centers. Alphabet is planning roughly the same. Meta has pushed its capital spending forecast up to $145 billion. Amazon is targeting around $200 billion. Just those four companies could pour more than $725 billion into AI infrastructure this year alone, and Nvidia sits at the center of almost every single dollar of it. Let's talk about the hardware driving all of this, because the numbers behind Nvidia's chips are just as staggering as the dollar figures. The Blackwell architecture, which launched in late 2025, delivered a massive leap in performance for both training and inference workloads, and it quickly became the backbone of nearly every major AI build-out on the planet. Later this year, Nvidia is expected to roll out its next-generation Vera Rubin platform, promising further gains in inference performance that could extend this entire demand cycle well into 2028. Analysts at Evercore ISI have projected that Nvidia's data center revenue alone could approach $750 billion across fiscal years 2026 and 2027 combined. That number is not about deals or financing arrangements. That is projected revenue from selling actual hardware, on top of everything else Nvidia is doing. Nvidia's networking revenue, the equipment that connects thousands of GPUs together into a single functioning cluster, grew by more than 160% in a single recent quarter, which tells you just how much of this build-out is happening beneath the surface, far beyond what most people picture when they hear the words AI chip. And it is not just American companies driving this. China is reportedly investing an estimated $100 billion into AI data centers as part of its own new infrastructure initiative, building a parallel ecosystem that increasingly operates independently of Western supply chains. That detail matters more than it might seem at first glance, because it suggests the global AI infrastructure race is no longer just about which company wins. It is about which entire technological ecosystem ends up defining the next several decades of computing, energy consumption, and national security policy. Now, if you are new here, this channel breaks down the biggest shifts happening in tech, business, and the future of money in plain English without the jargon. If that sounds like your kind of channel, tap that subscribe button, because what I am about to show you next is the part almost nobody is talking about, and it could change how you think about the entire AI trade. So why bring quantum computing into this conversation at all? Because while everyone was watching the money, a quieter and arguably more important story was unfolding in research labs and government offices. It has nothing to do with quantum computers replacing Nvidia's GPUs. In fact, quantum computers are nowhere close to being able to do that, and probably never will be in the way people imagine. The real issue is something most people have never even heard of. It is called harvest now, decrypt later, and it could turn today's most valuable digital assets, the very models that power this entire AI boom, into tomorrow's biggest liability. Let me explain what that actually means in plain terms. Every single day, massive amounts of encrypted data flow across the internet. Training data sets, proprietary model architectures, inference logs, trade secrets, all of it protected by encryption standards like RSA and elliptic curve cryptography. These standards have kept our digital world safe for decades because breaking them with a classical computer would take longer than the age of the universe, but a sufficiently powerful quantum computer, using something called Shor's algorithm, could theoretically break that same encryption in a matter of hours or days. Today's quantum computers are not powerful enough to do this yet. Most experts agree we are still years away from that moment. But here's the part that should genuinely worry you. Attackers do not need a working quantum computer today. They only need to steal your encrypted data today, store it quietly, and wait. That is the entire strategy behind Harvest now, decrypt later. Nation states and sophisticated hacking groups are already intercepting and archiving massive volumes of encrypted AI training data right now in 2026, while the encryption is still technically unbroken. They are betting that within the next 5 to 10 years, quantum hardware will mature enough to crack it open. When that day comes, whatever they stored years earlier becomes instantly readable. Your model weights, the actual intellectual property that companies spend hundreds of millions of dollars training, could become fully transparent to anyone holding the right quantum toolkit. For an industry that has just poured $750 billion into building and protecting these exact digital assets, that is not a small footnote. That is a structural risk sitting quietly underneath the entire AI data center race. This is not science fiction speculation either. Governments have already responded with real deadlines. The National Institute of Standards and Technology, known as NIST, has laid out a formal timeline for retiring vulnerable encryption. By the year 2030, algorithms like RSA 2048 and ECCP 256 are set to be deprecated, meaning no new systems should be built using them. By 2035, those same algorithms are expected to be fully disallowed across federal systems in the United States. The National Security Agency is moving even faster for national security systems, requiring quantum-resistant cryptography for new acquisitions starting as early as 2027, with full enforcement targeted by 2031. In June of this year, the White House signed an executive order titled Securing the Nation Against Advanced Cryptographic Attacks, converting what used to be general guidance into hard legal obligations. Federal agencies must transition their most sensitive systems to quantum-safe key exchange by the end of 2030, and to quantum-safe digital signatures by the end of 2031. There is a practical side to this that security teams are only now starting to grapple with, and it comes down to a concept called crypto agility. In simple terms, crypto agility means being able to swap out old, broken encryption methods for new, quantum-safe versions without having to tear apart and rebuild an entire system from scratch. Most data centers built over the last decade were never designed with that kind of flexibility in mind, because nobody was seriously planning for a quantum threat when those systems were architected. That means many organizations racing to build AI infrastructure today are essentially building on top of hardware security modules, the specialized devices responsible for managing encryption keys, that may not even be capable of supporting the new post-quantum algorithms without a significant and costly hardware refresh. Auditing those systems now, before quantum computing matures, is exactly the kind of unglamorous, unsexy work that rarely makes headlines, but could end up determining which companies weather this transition smoothly and which ones are forced into expensive, chaotic overhauls a few years from now. Here is the uncomfortable truth hiding inside those dates. Despite years of warnings, surveys show that fewer than 5% of enterprises currently have a defined quantum readiness strategy. Think about that gap for a second. Governments are setting hard legal deadlines, intelligence agencies are actively warning about state-level threats, and yet almost no company outside of the most regulated sectors has actually started preparing. That includes plenty of the same companies now pouring hundreds of billions of dollars into AI infrastructure. They are racing to build bigger and faster data centers, while the security foundation underneath those data centers is still running on encryption standards that have an expiration date stamped right on them by the United States government. So where does Nvidia fit into all of this? This is actually the most interesting part of the story because Nvidia saw this coming years before most of the industry did, and it has quietly positioned itself on both sides of the quantum equation. On one side, Nvidia has built a toolkit called QPQC, which stands for GPU Accelerated Post-Quantum Cryptography. In plain language, it allows companies to implement the new NIST-approved quantum-resistant encryption algorithms at massive speed and scale, using the very same GPU infrastructure that already powers their AI workloads. Instead of ripping out entire data centers to prepare for the quantum threat, companies can use Nvidia's own hardware to help defend against it. That is a genuinely clever position to be in. Nvidia is not just the company selling you the chips that create the risk, it is also selling you the tool that helps protect against that risk. On the other side of the equation, Nvidia has made a deliberate strategic choice not to build its own quantum computer. Jensen Huang, Nvidia's CEO, has made this extremely clear in public. Nvidia is not trying to become a quantum hardware company competing with the likes of IBM, Google, or IonQ. Instead, Nvidia wants to become the connective tissue that links every quantum computer in the world to classical AI, supercomputers. At its GTC conference this year, Nvidia unveiled something called NVQ-Link, along with a new programming interface called CUDAC Realtime, designed specifically to integrate quantum processing units directly with Nvidia's GB200 systems. The company even built something called the Nvidia Accelerated Quantum Computing Research Center, a facility explicitly designed to help quantum hardware makers plug their machines into Nvidia's AI infrastructure, rather than compete with it. Why would Nvidia do this instead of just staying focused on GPUs? Because quantum computers, even in their most advanced current form, need something classical computers already do extremely well. Quantum processors are famously fragile. Qubits require constant, precise calibration to fight off noise and prevent errors, a process that is incredibly labor-intensive and mathematically complex. It turns out that AI models are remarkably good at handling exactly that kind of calibration problem. Nvidia has built a model family called Ising specifically for this purpose, allowing quantum hardware experts who are not machine learning specialists to use state-of-the-art AI to keep their fragile quantum machines stable and error-free. In other words, the road to making quantum computing actually useful may run directly through the same GPUs powering today's AI boom. That is either a brilliant hedge against future disruption or a sign that Nvidia understands something about where all of this is heading that the rest of the market has not fully priced in yet. Now let's address the elephant in the room, because I know some of you are thinking it. If quantum computers are still years away from breaking encryption and years away from being genuinely useful for most workloads, why does any of this matter for the data? Center race happening right now in 2026? Here is the honest answer. And it is more nuanced than the scary headlines suggest. Quantum computers are not going to replace Nvidia's GPUs anytime soon, and probably not ever in the way people assume. The physics simply do not work that way. A single rack of Nvidia's most popular AI training chips draws somewhere between 120 and 140 kilowatts of power, with next-generation systems projected to push past 200 kilowatts per rack. A hyperscale AI campus running tens of thousands of these racks can consume hundreds of megawatts, with some facilities projected to approach a full gigawatt of power consumption. By contrast, a quantum machine supporting a couple thousand qubits runs on roughly 30 kilowatts total. Quantum computers are not going to absorb AI's massive compute demand. They cannot run today's AI workloads more efficiently, and they certainly cannot substitute for the matrix, math that trains and runs large language models. One industry expert put it perfectly. Think of quantum computers as an entirely different type of computer, built for entirely different use cases, not a faster version of what we already have. The real industries currently finding genuine value in quantum computing are narrow but important. Scientific computing and financial services are leading the way, using early quantum systems to model molecular interactions for drug discovery, optimize complex financial portfolios, and simulate physical systems that are simply too complex for classical computers to handle efficiently. Most other sectors, including the broader AI industry, are still in a watching and waiting phase. As one technology leader put it bluntly, we are not anywhere near the point where quantum computing meaningfully scales inside typical data centers. So no, quantum computing is not about to disrupt Nvidia's dominance in AI training and inference. That part of the bubble fear narrative simply does not hold up under scrutiny. But here is why the quantum problem still genuinely matters for the data center race, even though it will not replace a single GPU anytime soon. It changes the calculus of risk for every single dollar being poured into the $750 billion build-out. Companies are constructing data centers today that are expected to operate for 10, 15, even 20 years. The chips inside them will be upgraded constantly, but the underlying data, the model weights, the proprietary training sets, the encrypted communications between systems, all of that has a shelf life that extends well past the point where today's encryption is expected to become breakable. Every company racing to build the next massive AI campus is implicitly making a bet that whatever they encrypt today will still be secure in 2035. Given everything we just covered about government deadlines and the harvest now decrypt later strategy already being used against organizations today, that is an increasingly risky bet to make quietly in the background, while all the public attention stays fixed on chip shortages and power grids. And this connects directly back to the circular financing concerns we started with. When Nvidia backstops $250 billion in financing for a company like OpenAI to lease data center capacity, or commits to $500 billion in combined business with a partner like SK Group, those are decades-long bets on infrastructure that needs to remain secure and valuable for just as long. If the quantum threat accelerates faster than expected, and some analysts genuinely believe state-level actors could achieve meaningful quantum decryption capability as early as 2028, then a meaningful portion of the intellectual property underpinning this entire trillion-dollar AI valuation story could become exposed years before the infrastructure built to house it has even been paid off. That is the quiet, unglamorous risk sitting underneath the flashy headlines about chip deals and gigawatt data centers. It is also worth understanding who else is playing in this space, because Nvidia is far from the only company betting on quantum. Computing's eventual relevance, companies like IBM, Google, IonQ, Rigetti, and D-Wave have all been racing to build increasingly capable quantum processors over the past several years, each pursuing different underlying technologies, from superconducting qubits to trapped ions to the newer neutral atom approach that has generated significant excitement recently. None of these companies are trying to compete directly with Nvidia's GPUs, and that is precisely the point. Nvidia does not need to win the race to build the best quantum processor. It simply needs to make sure that whichever company does win that race is running its calibration, error correction, and classical support workloads on Nvidia hardware. That is a fundamentally lower risk strategy than trying to out-innovate an entirely different branch of physics. And it explains why Nvidia has been so willing to open its research center to outside quantum hardware partners rather than trying to build everything in-house. This is exactly why Nvidia's dual quantum strategy starts to make so much more sense once you connect the dots. By building CUPQC, Nvidia is essentially selling insurance against the very risk that its own massive infrastructure build-out is creating. By building bridges like NVQLink, instead of competing head-on with quantum hardware makers, Nvidia positions itself to profit from quantum computing's rise, no matter which company builds the first truly useful quantum machine. It is a hedge wrapped inside a growth strategy, and very few companies in the world are positioned to play both sides of a multi-trillion-dollar technology transition at the same time the way Nvidia currently is. So what does all of this actually mean for you? Whether you are an investor watching this space, a business leader planning infrastructure decisions, or simply someone trying to understand where the next decade of technology is heading. First, the AI data center race is not slowing down anytime soon, regardless of quantum computing concerns. The demand for compute is real. The revenue Nvidia is generating is real. And the fundamental usefulness of large languages, E-models across countless industries is real. Second, the circular financing concerns are legitimate and worth watching closely, because when the same handful of companies are simultaneously investors, suppliers, and customers of each other, the usual signals investors rely on to judge genuine demand become much harder to read, clearly. Third, and this is the part almost nobody is talking about yet, the quantum threat is not about competition. It is about the security foundation underneath everything being built right now. Organizations that ignore post-quantum cryptography today are essentially building a beautiful house on a foundation with a known expiration date and choosing not to look at the fine print. There's also a supply chain layer to this story that rarely makes it into the headlines. Nvidia's partnership with SK Group is not just about buying and selling business between two giant companies. It is specifically designed to secure access to high bandwidth memory chips, the specialized components that are in desperately short supply because of just how much AI infrastructure the entire world is trying to build simultaneously. SK Hynix and Samsung Electronics remain the two dominant suppliers of these critical memory components. And by working directly with Hynix on designing future generations of high bandwidth memory, Nvidia is essentially trying to lock in guaranteed supply years before its competitors even finish negotiating their own contracts. In an industry where chip shortages can delay entire data center launches by months, that kind of forward planning is not just smart business. It may end up being the deciding factor in which companies actually get to build the AI infrastructure they have promised investors, and which ones fall behind schedule waiting for components that simply are not available yet. None of this happens in a vacuum either. Financial firms, far beyond the traditional tech investing world, have quietly become major players in funding this build-out. Firms like Apollo and Blackstone are now helping finance billions of dollars worth of data center and chip deals, blurring the line between traditional private equity and the AI infrastructure race in ways that would have seemed unusual just a few years ago. When private equity giants start writing checks for GPU clusters the same way they once financed office buildings and shopping malls, it is a strong signal that the market increasingly views AI infrastructure as a fundamentally new asset class, one with its own risk profile, its own long-term value assumptions, and yes, its own exposure to the quantum security questions we have been unpacking throughout this video. If you found this breakdown valuable, do me a favor and hit that like button. It genuinely helps this channel reach more people who are trying to actually understand what is happening in tech instead of just reacting to scary headlines. The data center race is changing, not because quantum computers are about to replace GPUs, they are not, but because the definition of what it means to secure $1 trillion digital asset is shifting under everyone's feet, whether the market has fully priced that in yet or not. Let's zoom out for a moment and put the entire picture together, because these pieces only make sense when you see them as one connected story rather than three separate headlines. Nvidia has built an extraordinary and genuinely unprecedented position at the center of the global economy. It supplies the chips that power almost every major AI system on the planet. It increasingly finances the very companies buying those chips, creating a feedback loop that critics warn is inflating demand beyond what organic growth alone could justify. And now quietly, it is also positioning itself as the company best, equipped to protect the entire industry from a mathematical threat that most people assume is still purely theoretical. 3 storylines, 1 company, and an almost unbelievable amount of capital tying them all together. What makes this moment in history particularly fascinating is the timing. We are watching 3 massive technological shifts converge at almost exactly the same moment. The AI infrastructure build-out is happening at a pace and scale the world has genuinely never seen before, with more capital being deployed into data centers this year than most countries spend on their entire annual budgets. At the same time, quantum computing is crossing from pure academic research into early commercial relevance still. Narrow, still limited to specific industries, but no longer purely theoretical the way it was even 5 years ago. And simultaneously, governments around the world are, for the first time, setting hard legal deadlines, forcing organizations to prepare for a threat that has not fully materialized yet, but that could materialize with very little warning once it does. History has shown us again and again that the companies which recognize convergence points like this early tend to end up defining the next era of technology, while the companies that stay narrowly focused on their existing business model often get caught flat-footed. Nvidia's leadership clearly understands this. That is why Jensen Huang has spent the last 2 years talking about quantum computing at every major conference, not because Nvidia needs quantum computing to succeed in the next few years, but because Nvidia's leadership is thinking about where compute, security, and scientific discovery are all heading over the next decade, and positioning the company to be indispensable across all 3 fronts simultaneously. For everyday investors and business leaders watching from the outside, the takeaway is not to panic about quantum computers suddenly making today's AI investments worthless. That is not what is happening, and anyone telling you that is oversimplifying a genuinely nuanced situation. The takeaway is to understand that the risks sitting underneath the biggest technology story of this decade are more layered than the headlines suggest. It is not just about whether Nvidia can keep growing revenue at 65% year over year. It is not just about whether circular financing arrangements eventually catch up with inflated valuations. It is also about whether the digital foundations being poured today, quite literally trillions of dollars worth of encrypted data, proprietary models, and infrastructure commitments, will still be secure and valuable by the time quantum computing matures enough to threaten them. The honest answer is that nobody knows exactly when that threat becomes real in a practical sense. Estimates range anywhere from 2028 to well beyond 2035, and serious experts disagree meaningfully on the timeline. But the deadlines governments have already set are not speculative guesses about the future. They are legally binding requirements happening right now in real time, forcing the most security-conscious organizations on Earth to start preparing today for a threat many people still dismiss as science fiction. When federal agencies, defense contractors, and national security systems are all racing against 2030 and 2031 deadlines, that tells you something important about how seriously the people with access to the best intelligence on this topic are actually taking it, regardless of how the general public perceives it. So here is where that leaves the data center race as we head deeper into 2026 and beyond. The compute build-out will keep accelerating because the demand for AI capability across every industry on the planet is not slowing down anytime soon. Nvidia will likely remain at the absolute center of that build-out, both as the dominant chip supplier and increasingly as the financier tying the entire ecosystem together, for better or worse, depending on how you view the circular financing concerns. And running quietly underneath all of that visible growth will be a second, much less discussed race. The race to secure everything being built before the mathematical assumptions protecting it today start to fail. Companies that get ahead of that second race, the ones already implementing post-quantum cryptography, auditing their hardware security modules, and building crypto agility into their systems now rather than waiting until 2030 forces their hand, will likely be the ones best positioned to protect the value of everything the current AI boom is creating. Companies that ignore it, the encrypted data they assumed was permanently protected was never quite as safe as they believed. It is also worth pausing on how unusual this moment is compared to previous technology cycles. During the dot-com era, companies were often criticized for spending money they did not have on infrastructure they did not need. Today's AI build-out is different in one important respect. The demand for compute is real and measurable, with cloud providers regularly reporting that they could sell even more capacity than they currently have available. But the financing structures underneath that demand, the circular deals, the vendor financing arrangements, and now the largely ignored quantum security question, all echo the same pattern that experienced investors learned to watch for in previous cycles: growth built on genuine. Demand can still be fragile if the financial architecture supporting it is stretched too thin, or if a risk sitting just outside the spotlight goes unaddressed for too long. That is the real story behind the headline, not a battle between AI chips and quantum computers, because that battle was never actually happening the way clickbait headlines implied. The real story is about how an industry built on unprecedented speed and unprecedented capital is now colliding with a much older, much slower moving reality. The reality that security foundations built on mathematics eventually expire, and that the smartest players in the game are already quietly preparing for the moment when that expiration date arrives, even while the rest of the world is still debating whether quantum computing matters at all. If this kind of deep connected analysis is what you come here for, make sure you are subscribed, because the intersection between AI, infrastructure, and the technologies quietly reshaping them is exactly what this channel covers every single week. Nvidia's $750 billion bet is not going to fail because of quantum computing anytime soon, but understanding the quantum problem sitting underneath that bet is exactly the kind of insight that separates people who genuinely understand where technology is heading from people who are simply reacting to whatever headline crosses their feed next. One last thought before you go. The next time you see a headline about Nvidia signing another massive multi-billion-dollar deal, or another hyperscaler announcing another record-breaking capital spending plan, remember that the story is rarely just about chips and money. It is about power grids straining to keep up, memory supply chains being renegotiated in real time, financing structures that blur the line between customer and investor, and a slow-moving mathematical clock counting down toward a deadline most of the world has not even noticed yet. That is the full picture behind the $750 billion bet. And now you understand it better than almost anyone scrolling past the headline. Thanks for watching, and I will see you in the next one.